The functionality aims to provide air traffic controllers with real-time, immersive, and accurate information through a 3D video representation, replacing the conventional 2D screens. This enables controllers to monitor runways and taxiways visually in real time without relying solely on visual observation. The feature alerts the air traffic controller of a potential hazard when two aircraft are present on the runway simultaneously, enabling them to take appropriate action. The lead-on light function guides the aircraft to enter the runway after deactivating the stop bar when it reaches the stop bar for takeoff. Once the aircraft is ready for departure on the runway, the stop bar returns to the on state. The feature detects the direction and speed of moving aircraft, predicting potential collision points between aircraft in advance, and provides this information to air traffic controllers preemptively. The functionality detects the direction and speed of both moving aircraft and vehicles, predicting potential collision points between aircraft and vehicles in advance, and provides this information to air traffic controllers preemptively. The feature alerts when unauthorized vehicles or objects intrude onto the runway, or when an aircraft deviates abnormally from the runway, enabling air traffic controllers to take appropriate action. The feature provides alerts when unauthorized vehicles or objects intrude within the movement area, including taxiways, or when an aircraft abnormally deviates from the taxiway, enabling air traffic controllers to take appropriate action. The feature involves installing zoom cameras at the ALS starting point to provide video footage of landing aircraft, allowing air traffic controllers to visually monitor the landing gear, engine status, and fuselage when visual confirmation of landing aircraft is not possible due to low visibility conditions. The feature involves installing zoom cameras at the midpoint of the runway to provide video footage of departing aircraft, allowing air traffic controllers to visually monitor the landing gear, engine status, and fuselage when visual confirmation of departing aircraft is not possible due to low visibility conditions. The feature provides air traffic controllers with distance information between aircraft to prevent collisions between aircraft moving from parallel taxiways to the runway direction for takeoff. The feature provides information to air traffic controllers when two or more runway centerline lights are continuously turned off. The feature provides information to air traffic controllers when two or more taxiway centerline lights are continuously turned off. The feature automatically assigns a call sign to an aircraft when the transponder is turned off by the pilot after landing, as the absence of a call sign makes it impossible for air traffic controllers to identify the aircraft. The feature automatically assigns a call sign to an aircraft when it departs from the bridge or spot for takeoff, as the absence of a call sign may hinder air traffic controllers from identifying the aircraft. The feature provides time information to air traffic controllers starting 99 seconds before an aircraft's arrival at the runway threshold, enabling them to decide whether to allow the aircraft to take off or hold it. The feature involves installing LiDAR on the sides of runways and taxiways to accurately track the positions of moving aircraft. This is implemented to mitigate the confusion caused to air traffic controllers by the Doppler phenomenon, where aircraft may disappear and reappear on the surface movement radar during severe weather conditions such as snow, rain, or dense fog. The feature automatically guides aircraft by setting their path from the server to guide aircraft from the runway to the high-speed exit taxiway, and then to the bridge or spot. The feature enables air traffic controllers to guide aircraft from the runway to the high-speed exit taxiway, and then to the bridge or spot by clicking on specific points along the aircraft's path. Upon clicking each point, the guidance lights, such as the centerline lights, along that segment are activated to guide the aircraft. The system is designed to allow air traffic controllers to establish flight paths on the airfield, enabling them to set paths and verify predetermined aircraft guidance routes in advance. The system alerts air traffic controllers within 2 seconds if an aircraft deviates from the predetermined guidance route for directing aircraft from the high-speed exit taxiway to the bridge or spot. It then re-establishes a new path from the point of deviation to guide the aircraft accordingly. The system sequentially activates the centerline lights along the forward path of aircraft movement from the high-speed exit taxiway to the bridge or spot, covering a distance of approximately 300 to 500 meters. Lights that the aircraft has passed are turned off, providing precise guidance to the pilot along the designated path. The feature activates runway lights to guide incoming ambulances and fire trucks to the accident site in case of emergencies occurring on the runway.